All right, let me share my screen here. Um, I think this is the one. Yeah, okay. All right. So here's our new repository, Triton Data Center, Triton Cloud Images. Um, so this is going to be how we do HVM images going forward. They're compatible with both KVM and Bhyve. Um, And if you like, after you import them to your data center, you can set them to be Beehive only um, with UEFI, and that will enable doing VNC with them. So that's pretty cool. It took us a bit of work to get everything into that state. So we're really excited about it. Um, So the way this all works is we're using a combination of Packer and Ansible. So to get set up, you need a um, base 22.4 image. Um, Trunk doesn't work because of a bug with Ansible, um, and 21.4 also doesn't work. So it has to be 22.4. Hopefully that bug with Ansible will get worked out pretty soon, so that we'll be able to use 23.4 or 24.4 images going forward. Um, so that's the first requirement. You need allow IP spoofing uh, to allow for the guest networking. Um, Here's the command for how to do that in Triton, or if you're doing it on standalone SmartOS, you can just set the property on the NIC. After the VM is created, you need to add additional permissions, and this is something that you'd need either in Triton or in SmartOS standalone. Um, this is not something that is normally allowed for tenants, so you're not going to be able to do this in mnx.io. You'd have to have um, uh, your own servers that you're running this on, or um, like Equinix Metal or OVH, something like that, where you are in exclusive control of the hardware. Because granting access to these devices is basically going to allow writing directly into kernel memory. Um, so it's not safe to give to untrusted tenants. So if you're doing this, keep that in mind. This is not something you want to just enable for like anybody who's a member in your cloud. Um, but for the build zone, that is um, the only requirements. Um, there's some more documentation here about how the networking is set up, which I'll go over, but all of this is handled automatically in the build script. So we create a couple of network interfaces. Um, so the Packer Zero interface is used by the instance itself, and that connects over the images zero ether stub to do the routing, and then we set up the NAT configuration and a DHCP server because Kimu has a small DHCP server built into it. So when we're doing Kimu builds, we didn't have to worry about that. But Bhyve doesn't, so we're running our own with ISC DHCPD. Um, and so, like I said, all of that stuff gets set up automatically. But if you need to look into the details about how any of it works, because like something didn't work right or you need to troubleshoot something, um, this is kind of the documentation model of how it's supposed to work. Um, and then you can just run build all list, and it'll list all the targets. You run build all by itself, and it'll produce every image, or you can list individual targets. So you could do like, build Alma Linux 9 and Ubuntu 2004, and do just those two images. Um, okay, so that being said, each each image has its own HCL file, which is a Packer file. Um, and so the key bit here, the most important part, is the boot command. So that's basically going to tell Packer how to interact over the VNC console with the instance. Um, so the way Packer works is it's going to spawn a Bhyve instance, um, and it enables a VNC server on it. And then Packer will connect to that VNC server and interactively or semi-interactively send these commands. Packer doesn't actually know how to read the screen, and so you have things like wait, and so it's going to put in a small pause before the next bit. And so whatever you would do um, manually, interactively with the bootloader, um, which for Linux is going to be grub, that's what you would put in here into the boot command. And so, like, whatever you would type in to make the installer do an automated installation, like giving it like the location of the Kickstart file, stuff like that. Anything that's needed there, that's what goes into the boot command. And so you can see like Debian is a bit more involved, right? And Ubuntu is actually not that bad. It's just like the seed location. Um, and so once you have those in, these variables are pretty much the same for all of these files. And so like if you were making one new, most likely you'd be able to take one of these existing HCL files, clone it, and modify it as needed. And then you play around a bit with the bootloader in order to put in all whatever information it needs to do an automated installation. And then your Packer side is done. In the HTTP directory, we have all of the installer automation scripts. So we've got the Kickstart files for Debian, the pre-seed, and then Ubuntu uses something like Cloud Init, but not exactly like Cloud Init. So anyway, that one's YAML based. And so if you're doing one of these from scratch, the important bit is to make sure that the drive partitions are set up correctly to work with both UEFI and BIOS to make sure that it's compatible with KVM and Bhyve. In most cases, you can basically just like copy out what we have or whatever whatever OS you're booting or whatever distribution you're booting, creating a layout that's similar to what we have here. So we've got like a rel-derived example, a deb-derived example, and Ubuntu's cloud config-derived example. It shouldn't be too difficult to add like Void or Gentoo if somebody wanted to, if you know how those installers work. This stuff's pretty straightforward. I was doing like Debian pre-seeds like 15 years ago stuff. So like this was all pretty familiar to me. And it was really straightforward creating it. So the process will be, let's see here. Where's the build script? There it is. Okay, so the build script is going to do some setup of the zone. It will set up the networking services. It'll set up the NAT, and it will set up DHCP, and then it will install the Packer plugins that are necessary. So it's going to be our custom Bhyve plugin and the Ansible plugin. And then it will create a ZFS data set to do the installation too. And then it'll kick off the installer build. So when that happens, you can connect your own VNC client to it. When you do that, you want to make sure that you enable other connections because Packer needs to be connected over VNC as well. And so if you don't allow other connections when you connect to it, it's going to kick Packer out and that will fail the build. So make sure that you have that option set. And then by default, we'll use a random VNC port and a randomly generated password. But you can in variables.packer here, you can change these to use no password and a specific port so that you can connect to the same thing consistently over and over again. But when we do this, like in Jenkins, eventually, we want those to be dynamic. But doing it yourself in your own build system, or like while you're developing it, it's a good idea to set those to something static so you don't have to go hunt for it. So it'll launch the VM and enter all of the commands into the bootloader, and then the normal installer program will take over and do everything else. Assuming that your automation script is correct, so whether it's pre-seed kickstart or cloud config, and the installer will actually complete everything successfully. Once it gets to the end of that, it will reboot the VM, and then it will come up like in normal mode. So like no installer anymore. You're actually running like the real like VM. And then it will connect with Packer or with Ansible. And so we've got some roles that we've set up in order to do the guest configuration. And so this is going to be anything that needs to be done after the installer or things that need to be done that are more complex than reasonably could be done in the installer. Most installers have like an early command and a late command hook so that you can do some things. But it would be fairly complex to like overload that like late command with an entire shell script to do all this stuff. And we like the idea of using Packer or Ansible because it's declarative. When there's an error, we know like exactly where the error happened, exactly why the error happened. It's pretty easy to debug. And it's fairly widespread use these days, so information about like how to use it and configure it is all readily available. So for the roles, first we run the SmartOS guest, and we'll just take a look at the tasks here. So common is these are things that are going to happen on everything, right? So we disable root login, seed some information to Cloud Init, copy in our guest tools, we create a guest systemd service for Triton, and that comes from these files. They're smart to see. There you go. So that's this script that's going to run. And that's going to do a couple of things like ensure the root password is set correctly, and run the like the first boot stuff that a new instance needs to do when it comes up. And these are actually things that Cloud Init should do, but doesn't yet. So we'll need to get some updates into Cloud Init to get that stuff to go correctly. Let's see what else. Guest service, MOTD, so some branding information, and FS trim cron job. What that does is, so if you have a Bhyve instance, when you unlink data from the file system, an unlink operation is just modifying the inode table, and the actual blocks on disk are still consumed. As far as ZFS knows, that data is used. There's no way for it to know that that's free. And so you end up with your zvols always grow in size, and the size of the zvol doesn't accurately reflect the data that the guest cares about, right? And that can run into problems later on if you're trying to do a migration or if you're trying to do snapshots. You can be over quota, even when like the guest thinks that it has 50% free. ZFS doesn't know that all of that data should be free. And FS trim will correct that. That's how the FS trim operation from the guest kernel gets interpreted by Bhyve as a way to let ZFS know these blocks can be freed. So that will actually shrink the consumed size of the zvol, which makes it a lot easier to stay under your quota, so that you can do snapshots if necessary, or do migrations, which also requires snapshots. So, and then we have, let's see here. Oh wait, main is where we start. Yeah, so we run some like distro specific ones, and I'll just do Ubuntu as an example. So we purge out some packages that come installed by default that we don't need in a cloud environment. And for Ubuntu, this actually ended up being like over a gigabyte of stuff that we were able to remove. Let's see here. Okay, and then we remove the apt-cache and snap. Maybe there's a better one. Yeah, no, okay, so these are basically let's see here. Okay, so Red Hat. Rocky and Red Hat look like they're redundant, probably. But so anyway, like we remove some software, we add some software, do some Cloud Init setup, and some UDEV rules, and then we jump into the common stuff. And then once that is done, we go into the cleanup VM, and that's gonna finalize all of the data and make sure that we haven't left any crust on there. someone's audio is cutting in here. Um, so that's going to do things like make sure that the SSH keys are cleaned out and stuff like that, and some other like various stuff that might get left around the file system. Um, and so this is basically like something that we would want to run. Like these tests would apply anytime you're taking a running instance and preparing it to be a virtual machine image. Um, so this is going to clean out everything that is like unique ID to that instance, so that when it boots up, um, the new instance can uh, like initialize itself with its own new identity. Um, and then, so after we're done with Ansible, we jump back in here into the build script, and so Packer is going to we'll do a ZFS send of the data set. And so that happens for us automatically. And so we do, we can destroy it and then generate the manifest. And that happens up here. So we've got a manifest template here. Okay. So we pop into some values to that and gzip the image. And then when we're done, it's ready to go. And we just copy that into into a test data center and run those instances. And once we get it behaving the way we want, then we publish them. So it's actually a really, really straightforward process compared with what we had before, which was like each distro type had its own completely custom like VM turnup, scripting, like different ways of copying stuff into the VM. And it was like every distro was its own repo, completely different from the ground up. And now we've got a unified framework that's going to work the same for any images that we produce. So as an example of how easy it is to add something in, Debian 12 was released while we were defining this system. And Nick actually put in the Debian 12 one in like an hour because he just copied Debian 11, made a couple of tweaks to it, and we tested it out, and it basically just worked first shot. We also have what we're working on is CentOS streams. So we're going to have stream 8 and stream 9. And these are basically just copies of either Alma or Rocky. I'm not sure which one. But these are in testing right now. Nick is on vacation. Otherwise, this might well have been done this week already. So yeah, it's really easy to put new stuff in. When a new version of something comes out, it's going to be super easy, super quick to get those new versions. And we've also started looking at converting our BSD images over to it. So our plan is to do at least FreeBSD and NetBSD, and at possibly adding OpenBSD down the line. But I know there's people right now that would like to use FreeBSD and we use NetBSD Images as part of the package source build process. So Jonathan does some of the development work using NetBSD instances, so he needs those. But yeah, so like adding those in is going to be a lot easier than our process that we had before of like creating something from scratch. So this should be a lot easier for anybody else to contribute. Like if there's a distro that you would like to have, or if there's some custom images that you'd like, that should all work. We're also thinking about putting in a Windows HCL file. The caveat with that is that we can't distribute images of Windows, and we can't distribute the install media for licensing reasons with Microsoft. But basically, the idea is that we would have the HCL file and the installer automation. And basically, like you provide your own URL for the installer, and you can generate your own images with it. So I think that covers pretty much everything about how it works. If you have any questions about this?
Does the Packer automation support serial ports also, or is it only BNC?
It does support serial ports also. We have, let's see here. Let's see here. So here's where the Bhyve plugin is. So I do know that when the Packer command runs, it spits out exactly the command that it executes to spawn Bhyve, and in that has the like the console is on such and such. So it's there, but I haven't used it largely because the Linux installers don't enable Serial Console by default. And so um, if you're doing a new one and you enable that through like Grub, that would totally work. And actually, I think like in Debian,
Yeah.
yeah. So we enable the serial console there, right? Yeah. So that does work.
Okay.
Yeah.
Yeah. I'd be curious to try to at some point when my copious free time, to get like a NixOS image running. NixOS I don't think really supports Ansible because it's like completely different. But presumably if I could inject in just enough stuff so that it runs its own.
Right. So
then
Ansible does also have a raw module. So what we could do here is oops, not there. Ansible. So you could do like a role for Nix. Okay, so like we've got SmartOS guest here, and then probably something like something like this that's going to say like if it's Nix, then do this. And then for the tasks, actually let me do clean up. It's a better example.
And Nix does support Python.
Yeah, it's just its configuration is. I quickly looked and I didn't see anything Ansible for NixOS, but
Right.
um,
Yeah. So
in theory,
the
the
really
Nix
nice thing about
configuration would be a very
Ansible,
straightforward config. Go ahead.
yeah, the really nice thing about Ansible is it's really agnostic to whatever the target host is running. The way it works by default is like whatever you say to do, like uh,
Just run the command dnf clean all, right?
um, yeah, okay. So here, like this one, file, right?
Yep.
This path needs to be absent. Okay, so what it's going to do is it will take that snippet and generate a Python script to delete that file.
Mm-hmm.
And so, like, if it's something that like you could write a Python script to delete a file and then just execute on NixOS, then it will work with Ansible. The only thing that you need is a Python interpreter, and everything else, like there's no agent for Ansible. You don't have to have anything custom for it. And what you can do is, so these right here, like command and shell. So command and shell are the module names. You could change this to raw, and then instead of doing a Python script, it's going to create basically a shell script with like exactly this text, like whatever text you put in there. It's going to create a file with exactly that text, make it executable, and execute it. So you can literally like um, you can use Ansible to manage like switches as long as you've got um, a way to log into it on the command line. Um, you know, it will actually like whatever you say, like raw commands, it will execute those in whatever shell environment happens to be on the other side. Um,
Okay.
So like that would be like worst case scenario, you know. I have some Ansible playbooks for like SmartOS Global Zone in order to set up package source and install the Python interpreter so that it could do everything else with Ansible. You know, so like my playbooks for a global zone are basically like the first couple of things are you know, raw set up package source, raw package in install Python, and then everything else will work normally. Um, so
Cool.
that's always an option for something that uh, Ansible doesn't know where the Python interpreter is. Um, and you can even tell it like to use an alternate Python interpreter path if you need to. Because like it detects SmartOS and assumes that the Python interpreter is going to be opt local bin Python. But in a global zone, that's going to be opt tools bin Python, right? And so you can tell it like for this set of hosts, the Python interpreter is going to be over here in this other location instead. And then it'll just use that. So yeah, that's another reason why I've grown to like Ansible a lot is it's super flexible and it even works with systems that Ansible itself has no prior knowledge of, which is super cool. So yeah, excellent question, by the way.
And the only difference I think was as Windows uses like PowerShell stuff for Ansible, so that would be one difference.
Right. Yeah. Yeah. But even still with Ansible or I mean with Windows, like you can just say raw and then whatever commands you do, it would just execute natively in whatever shell environment there is. So like you could do like Windows 2000, which doesn't even have PowerShell, it just has cmd.exe, right? You can do raw commands there, and it would work with that as well. So raw is always like no matter what, if you want to use Ansible with something, you can always specify raw, and it will still work, which is super handy. Yeah. Any other questions about this process? So if we want, I could go over how we do LX images as well, because it's a bit of a different process, but Mike Zeller kind of rewrote it about 2 years ago, which makes things a lot easier for LX images. Okay, so since we've got 20 minutes left, I'll hop into that. So we're sharing the image creation process with OmniOS now, which is good because it expands the pool of developers. For example, they just added in Rocky Linux a couple of days ago, and so we're able to benefit from that. And I'll be putting out some Rocky images later this week. But basically, so let's take a look at the Rocky one. We start with the Docker image for whatever distro. So we spawn the Docker image, and then so all of our Docker files are basically the same thing. We set a couple of variables, we copy in the helpers, and then we run the build sh script. The build sh is custom per distro. So like, this is what the Debian one looks like. This is what the Rocky one looks like. So we install some packages, do some systemd stuff, a couple of other tweaks, and then this stuff all runs in the Github action. Oh, there we go. And so this is actually like the script that's going to run here. So we cd to the target directory, docker build, docker cp, and then upload URL. So those all get stuck into, let me go back here, tags, all of these. And so we've got these tarballs, which are basically a tar of the root file system, right? So then we take those into the our SmartOS LX image builder. And so this is in Rust. And let's see here. Most of what happens is here in guest. We figure out which guest type it is. And then we do a couple of things that are SmartOS specific that wouldn't really work well with like OmniOS or with Open Indiana. So it's like our like Triton specific stuff and things that interact with like the MData client tools. And then ZFS send that out. And so it's actually a pretty quick process. I've been working on, let's see here. Oh, wait. this one over here. I've been working on adding Alpine Linux back in because we have an Alpine image, but it's 6 years old now, which is terrible. And I really I really enjoyed using Alpine for LX zones. So I want to add that back in. But once I get that finished off, I'll have some new LX images to publish out, which will include the brand new Rocky image and the updated Alpine image. So yeah, that one's pretty straightforward. One of the cool things about this Rust program, it just takes a tarball as input. And so like LXC has a bunch of images for their stuff. So instead of taking these LX images that we produce, you could just take something from like from LXC or getting a root image from pretty much anywhere and converting it. Like Red Hat has their like UBI images, like universal basic image, right? And there's tarballs of those, and so you can just like grab a tarball, throw it in this thing, and output yourself, an image for like whatever that thing is. So that one's super cool too. And lots of thanks to Mike Zeller for creating this process. So yeah, any questions about that one? All right. Any questions about anything? Absolutely. Yeah. Yeah. Hmm. Right. Yeah. Yeah. Our goal here is to produce images that people want to use, um, whatever that happens to be, you know. Like I was saying to someone else a while ago, like if the industry as a whole decides that they want, um, you know, Mandriva, um, and like that's the new like corporate Linux that everybody like tacks onto, like we'll start making those images. We have no preference. We just yeah, I mean whatever. Like we're gonna produce images that people want to use. Um,
There's a question in the chat.
so yeah, see, there was a question here. Um, how about a reroll of base64 trunk? So the first thing I have to do isn't package in remove npm. Um, hmm, that's not a bad idea. Like we could do a 22 or a 22.4.1. Maybe I can talk to Jonathan about that. but I think if you use trunk already, that should be taken care of. A re-roll of trunk. Okay, yeah, um, yeah. I'll mention that to him, and we can probably get a new trunk out pretty soon. Yeah. Yeah, so for the audio, Nam says the trunk images get rebuilt every once in a while, and we just had a unfortunate timing situation with um, when the last one was produced and the fiasco with Node and NPM. Um, but yeah, that's a good point with NPM. So we'll try to get a new trunk base image out fairly soon.
Thank you very much for the questions. Is there any other
Yeah.
topics or questions people had? All right. If not, I guess we'll end a few minutes early. But thank you everybody for attending. I just want to say, also, like I said, we did the image process today, but and I'll place this in the Discord and some other places again. But if you have questions or ideas for topics, please let us know. Because we like to talk about what we're doing, but we also want to tailor things to questions or things in the community that people are curious about or want to see. So please give us suggestions if you have something. And then the other thing is to, just like Nahum did with his Tailscale stuff, like in WireGuard, like show us what you're working on as well, because we'd love to feature stuff that's going on in the community as well. So if you have things you want to display or you want to talk about a topic that's something you're working on, we can do that as well. So please, if you're working on something, let us know. And I'm sure like other people in the community want to see it, because sometimes it's like somebody's working on something really cool and the connection isn't made. So this is a great place for us to meet. So if you do have something you want to show, let us know and we can try to work that as well. So yeah. Well, thank you everybody. If you have questions or things that come up after this or things, ping us on the Discord. We're also on IRC, so bring things up there as well. But appreciate everybody's time, and we'll see you on the next office hours. Thank you very much, Brian.
You're welcome.